you want to do Henderson-Hasselbalch, it says pH, pKa, and I'll put it this way, plus log base over acid. That means conjugate base, conjugate acid.
Okay.
I don't care whether I write it like this. Now when you're titrating, what happens to the concentration of this, or the amount of this?
Increases.
No.
Are you
Titrating, because this is an acid, you have to add hydroxide ion.
Oh, okay.
So this is going down, and this is going up. At the equivalence point, there's none of this. It's all been converted to the salt form. That's why you're doing the hydrolysis problem. The only thing you have at the equivalence point is the salt. Remember, when we're doing stoichiometry, acid plus a base gives you salt plus water. No excess acid, no excess base. Otherwise, we'd be in what? A buffer region.
Oh wait, so that basin acid is not the actual basin acid, the conjugate basin acid?
Yeah, that's, when we're doing this, it's always acid 1, base 1. Remember we did that with the conjugate acid-base pairs. So this is the acid, that's the base. Now when we get to none of this left, we now have the salt, which we now do the hydrolysis reaction, which is, we talked about for the weak acid, anion hydrolysis. This one gave you the cation hydrolysis. So we use that terminology also because that was in the book. So here, for instance, this is a cation, ammonium, cation hydrolysis. Notice I said in the lecture, I talk about the acid and I give you the base in the quiz, or vice versa, to see if you can extend your thinking. Okay, so when lecture I talked about this thing, but again what happens is, got my minus sign, that's why it didn't work. Okay, so this was the anion hydrolysis. And the reason you got a basic solution out of that, because you have some excess hydroxides. There's the cation hydrolysis, you get some extra hydrogens, you get an acidic solution.
So just make sure, so when they refer to the base and acid, they're talking
This
about
is about the conjugate
products.
acid-base pair always.
Okay, so it's about the products, not the reactants. Okay.
Now the way I did this, I'll come back to this because you asked about that one. I said here's Ka, hydrogen ion, anion over Ha. And I said what happens at the half equivalence point, I'll write it like this. Zero. It's half the original concentration of HA. Okay? And what's the other thing? Basically, these two numbers are the same number. And so I said if you're at the half equivalence point, there's half of this left, and half of it's been converted to this. So these two numbers are the same. So they cancel out. And then you have Ka equals hydrogen ion, or you take the negative log of both sides, pKa is equal to the pH. What happens if you get to the half equivalence point? Again, this number equals this number. What's the log of 1? Everybody knows what the log of 1 is. What is it?
0.
0. Oh, maybe not, but I pretend you do. Because I said, oh, you know all your algebra things. So it's 0. So I take the log of 1, it's 0. pH is equal to pKa. Oh, this 7, I started grading somebody's paper and they kind of said it and I put it on my paper instead of theirs. That's okay, I remembered to write it on the paper, so 7 showed up.